Hi, my name is Pedro Ramirez, and today we'll be trying to find if two triangles are similar. Alright, so the technological knowledge. GSP differed from a static lesson because I was able to use a circle to construct a perfect triangle and construct a similar one, only smaller. And I did this by using perpendicular lines and midpoints. As opposed to a regular class, I remember, the triangles they're just given to you, so you just got to figure them out. But I think this was it's a lot funner because you actually get to use your hands and construct them yourself. The pedagogy knowledge, I would definitely use it as a teacher. I think this is a great way for students, to get the accurate measurements because, like I mentioned before, you get them in paper and you use your protractor, and a bunch of us always got different measurements for them. Um, so questions I would ask would be, what are the angle measurements? What are the lengths of the sides? And the final question, are the triangles similar? And I would definitely have students construct these triangles. I think it'd be fun for them to get them to work with their hands a bit. The content knowledge, I would like students to understand how to tell that two triangles are similar. Obviously, that's the point of this. I would also love for them to discover, that there are more ways than just this one that I'm going to show to find if two triangles are similar. For example, you can use side angle side, the side side side, or angle angle angle. Like I mentioned, I think it's better for students to have a visual representation and be able to play around with it. Alright. So I started with this circle right here to construct my triangle. So we are trying to figure out if two triangles are similar. So in order to know that, we need to know a couple of rules. But first, the angles have to be congruent. And I remember growing up, congruent, I had a hard time trying to figure out the definition. I always forgot. So congruent means that the angles have to be identical or equal. The second rule is the sides have to be proportional, and proportional means they have to be properly related. So like I mentioned, I use this circle right here to find our triangle ABC. There it is. And we have, using the midpoints and perpendicular lines, we were able to find triangle DEC, which should be the green shaded area. Alright, so we want to find out if triangle ABC and triangle DEC are similar. So we have our rules, so let's get to it. We need to find the measurements of the angles. So let's just hide this fella right here. Right, so let's find the measurements of triangle ABC. Right, here we have them. The measurement of angle ABC is 90 degrees. Measurement of angle CAB is 45 degrees. And the measurement of angle BCA is 45 degrees as well. So now let's find the measurements for the triangle DEC. So the measurement for angle DEC is 90 degrees. Measurement for angle CDE is 45 degrees. And the measurement for angle ECD is 45 degrees as well. So are our angles congruent? Yes, because angle ABC corresponds to angle DEC, and they're both 90 degrees. Angle CAB corresponds to angle CDE, and they're 45 degrees, as is angle BCA and angle ECD. So first rule is correct. The angles are congruent. Let's move on to the second rule. Are the sides of these two triangles, are they proportionate? Now we have to measure the lengths of the sides. So the measurement of AB is 3.74. Measurement of BC is 3.74, and the measurement of AD is right here is 2.65. Now AB corresponds to DE, and the measurement of DE is 1.87. Are they proportionally related? Well, if we add 1.87 plus 1.87, it equals to 3.74. So those sides are proportionally related. And side BC is 3.74, and CE corresponds to BC. And again, 1.87 is half of 3.74. So that side is proportionally related. Now AD, this part right here, and DC are both 2.65. If we add those together, then the result is 5.30. Is that proportionally related? Well, if AD is 2.65 and DC is 2.65 and D is in between A and C, then they are proportionally related. So, have we met our second rule? Yes. Now, we also have to find that the ratios are equal to each other. So, the ratio of DE over AB is 0.50. The ratio of CE over BC is 0.50. And the ratio of DC over AC, notice that it's not DC, AD, sorry. It's DC over AC, and the ratios are all related. So triangle ABC and triangle DEC are similar triangles. Now let's try this problem. We want to figure out if triangle DGF is similar to triangle KLM. So the measurement of angle DGF is 90.31 degrees. And the angle that corresponds to that is KLM, and its measurement is 83.47. And so the angle GFD is 44.85, excuse me. And the angle that corresponds to that is LMK, and its measurement is 48.05. We had angle FDG equal 44.85 FDG, and MKL 48.48. Now we see that the angles are not congruent, so we can so we didn't meet that rule. So these two angles are not similar. You can also tell by their sides. DG is 4.37 and LK is 2.64. 2.64 plus 2.64 is, let's see, 8, 12, 5.28. And that is not what this equals to. GF is equal to 4.37 and ML is equal to 2.66. And they are not proportionally related, nor is KM and FD. So in conclusion, these two triangles are not similar triangles. And that concludes my final presentation. Hope you guys enjoyed it. Thank you.